This is what is this? You know, I should know that. This is code analysis for chapter 5. This is the first one, and this is all about Boolean values. You wouldn't say Boolean to a goose. You could do, but it did have no effect. I'm digressing. We're now on in chapter 5 looking at the values you can put into Boolean values. And the first question we've got is, what happens if you take a Boolean value like, for example, var it is time to get up. I haven't got the T, the 2 hasn't got a capital. I've got to get it right. There you go. Time to get up equals true. Not Fred, true. T-R-U-E. Okay, so now I have a variable called it is time to get up. And if I type it, it is time to get up, it says that's got true in it. If I alert this, which means try and show it on the screen, what do we get? Well, the nice thing is, boom, you get the word true. Because whenever JavaScript tries to display a value that contains something, it tries to do a sensible conversion of that thing to a textual, yeah, that's right, textual version. And in the case of Boolean, true will come out as true. A number comes out as a number, and a string comes out as a string. This is actually not, it isn't a given. This is happening because the people that made JavaScript have made it go like that. And so it's worth knowing. The next question really is, do we have a function called Boolean which we can use to convert things into Boolean values? Because when I was playing with, I'll just get that away. When I was playing with numbers, we could say things like make a string variable var string number, and we'll make that equal to 99. Now we know that that's different from var number equals 99, because if I say type of number, it says, oh, type of, not type. I can't type of number, it goes, ooh, you're a number. If I go type of string number, it goes, oh, I better put the brackets in, hadn't I? Otherwise it won't work. Yeah, otherwise it won't work because that's spelled in there. Why am I whispering? I don't know. That's the string. So just to try and make this sensible for everybody, including me, I've got a variable called string number that holds the characters 9, 9. I have a variable called number that holds the value 9, 9. So I can say things like number plus 1, and I will get 100 because that is number plus 1. Wonderful. Now what we discovered in a previous chapter is that we can take a function called number, and we can give it a string, in this case string number, and it will return a number, a value. It'll convert that string into a number. Okay, that's fine. What about truthy and falsy? We know there's these ideas of JavaScript looking at a thing and going, aha, you're true, or aha, you're false. Right. Is there one called Boolean that does the same thing? And the answer is yes. I can say Boolean, and I can give it the value 1, which we know from the truthy rules means this is actually going to be true, and it'll go true. If I go Boolean 0, which we know from the truthy rules is actually going to be false, I get false back, and the other rules are obeyed too. If I go Boolean and empty string, then the truthy rules say that empty strings are false. The question in the next question in the, so having got having a Boolean thing which will do the conversion for us, the question in the book, which I will now ask myself, is what about negative numbers? There, what are they? Are they true or false? So we go Boolean, and we can find out by experiment. So I put -1 in there, boom, and out comes true. Yeah, the thing to remember about truthy and falsy is that the true tends to mean something is there, whereas false means nothing is there. So empty strings are false. The value 0 is false. Any other string is true, and any other number than 0 is also true. What about infinity? Because if I go 1 divided by 0, Java says that's infinity, which is where Buzz Lightyear comes from, or something. Anywho, is that actually going to be truthy or falsy? Well, madame et monsieur, you could faites vos jeux, you could place your bets in a really bad French accent, or we could ask Boolean. So give Boolean 1 divided by 0. And this will tell us, because 1 divided by 0 is infinity, whether Boolean, whether it's true or false. It's true. So it turns out that infinity, which is the biggest number you can have plus the biggest number you can have plus the biggest number you can have, is not false. So keep that in mind if you're doing sums. And what about not a number? So if I do something really stupid, like try and divide a number by a string, which is very silly, even if the string is Rob, it comes up with nan, which we know is JavaScript's way of saying, you've just done something stupid. And therefore I'll give you a number that has no meaning, and it has this special way of keeping track of that, called not a number. Is that true or false? Well, let's use Boolean to find out. So I go Boolean, I divide 1 by Rob, which other names will also give the same result. This is me being an egomaniac. There you go. And it's false. So not a number is falsy. So you keep in mind that. And so effectively, if there's something there, then it's going to be true. If there's nothing there, or nothing meaningful there, it's going to be false. And the only thing to bear in mind is that actually infinity, which you may think is ambiguous, isn't. It's always true. Now, final bit of this is, what about if I start combining Boolean logical values with numbers and strings? If I go 1 plus true, is this legal? Will it make an error? Will my head catch fire? I hope my head doesn't catch fire, but I don't think it will. 1 plus true is 2. In other words, the word true equals 1 as far as JavaScript is concerned. That's quite, that's reasonable. There is some weirdness though. What about true plus 1? Plus 1. Yeah, that's true. That's good. What about strings? So if I go hello plus true, well, that gives us hello true, which is, yeah, okay, I can go with that. So what happens is that JavaScript does the thing it thinks is most sensible. It takes whatever you are trying to do with it and makes a version of the value, a realization, if you like, of the value, which matches the context. So in a arithmetic situation, if I'm working with numbers, true becomes 1. And just to prove, in case you weren't believing me, 1 plus false should give, at the back there, your hands up, oh, jolly good, yeah, I agree, should give 1 because false is regarded as 0. And hello, but hello plus false will give hello false because it's converted to a string now. So yeah, keep all that in mind. One of the things I would say, it isn't in the book, but I hope you can figure it out from my tone of voice, is you should not ever combine Boolean values and numeric values in a program that you've designed to do something. It's a very silly, strange thing to do, and I really wouldn't condone it. It might work, but no one else will understand it when they try and read your code, and they certainly won't think, thank you for doing that. So you should keep them distinct and separate. But if you do happen to make a mistake, the point I will make is that your program will keep going. It will do something consistent, but that thing might not be what you want. So keep all that in mind. And with that, we can go back to chapter 3 and we can do some stuff on Boolean expressions.